So can someone tell me what is the population of interest that we are talking about for this question?
The weight of coffee bags delivered by the machine.
Okay, so the population is the weight of coffee bag. We don't know how heavy is it, correct? In this case, weight of coffee bag. Okay, weight of coffee bag filled by this machine. Okay, good. Now, so they say that this is, they say that the variation of the weight can be modeled by a normal distribution. So if my variable is the weight of the coffee bag, so it's a normally distributed with the mean, which is unknown, but the standard deviation is 10 grams. Right? So now my question is the distribution of the sample mean weight of bags of ground coffee normally distributed with a sample size of 15 and 20? Okay, with the sample size of 15 and 20. Yep. Sebastian, can you answer this question and tell me why? Sebastian, please.
One second.
Is the distribution of the sample mean weight normally distributed? Sebastian?
I reading back the question because I did the I did the calculation. I didn't see the.
Yeah, I'm asking you now. I'm asking you now. Can you try to give me the answer? Is a yes or no?
Yes.
Yes. Why?
Because it is in the question it states it is already modeled by a normal distribution. Therefore, any sample mean weight is already normally distributed.
Yeah, because the population weight of coffee bags is normally distributed. You must say because of this. Okay? Got it? Regardless, according to central limit theorem, the population weight of coffee bags is normally distributed. So regardless of any sample size, the distribution of the sample mean will be normally distributed as well. Okay? So now since Sebastian, you have calculated, can you tell me what is the width?
10.12.
Okay. How do you get 10.12? Can you give me what you substitute in? Because the question asks you to show 10.12. So how to show 10.12? You have to give me all the value here.
Times 1.96 times 10 over square root 15.
10 over square root 15. Yes, you are right. So that is for part 1. Am I right? For part 2, you have to do the calculation by yourself. Am I right? So it's 2 times of, it's also 95%, so it's 1.96. So it's 10 over square root of 20. Christopher, do you mind tell me the answer? It should be less than 10.12, am I right? Christopher? Christopher not in?
No, I'm in this.
Yeah, can you tell me? You should have done it, Christopher.
It's 8.765.
Okay, the question say round off to, did the question say round off to how many decimal? Since the first part, they give us 2 decimal, you must give me 2 decimal. 8 point. Again, Christopher,
8.77.
77 gram. Okay, should be narrower. Okay, we are done. Yeah. So I purposely ask this question is because when you're writing a report, you must justify whether the thing is normally distributed or not. If it's not normally distributed, we cannot use this formula at all. Are you clear? Okay. So you have to say according to central limit theorem. Okay, let's go to the next part. Okay, can anyone tell me that the rest of the question, what is the parameter of interest here? What is the person trying to do here? Yeah. How to?
Parameter.
Yes. What is the
Mean weight,
parameter
mean
of
weight, mean weight.
interest? Okay. How,
Teacher,
sir, can you give me a complete one instead of just say mean weight?
teacher, wait, can the population, right? Why include weight? Ni?
I said, what is the parameter of interest? That means what is the parameter of interest that you are trying to do now? What are you trying to predict here?
The mean
What are
weight
you trying to justify?
of coffee bags.
Yes, you are trying to predict the mean weight of ground coffee bags. Huh?
Teacher,
Hmm?
can you go back? The previous slide. or
Okay,
something?
here.
The population, right? Why
Mm.
include the weight?
Yeah. Is the coffee bags filled by this machine? Yes, thank you. Yes, you are right. So I can start off now. Thanks, Hauja. Okay, so the parameter of interest is to predict the mean weight of ground coffee bags produced by this machine, okay? Or filled by this machine. Okay, so in this situation, they are not trying to justify a claim. So what are they trying to justify for this case? What is you want to predict the mean weight of ground coffee bags filled by the machine? Okay, but what are you going to do? What decision are you going to make? You want to decide whether you want to adjust the machine or not. Am I right? And what is the criteria that they are talking about whether to adjust or not to adjust the machine? So this is called the things that you want to justify. Like for example, in our textbook, correct? We all the question will say, someone claimed that it is increased or decreased. So in this case, it's not a matter of the claim. It's a matter of the decision whether you need to adjust or not to adjust the machine. So you are going to predict the mean weight of the ground coffee bags filled by this machine so that you can decide, so that the quality controller can decide whether to adjust or not to adjust the machine based on the measurement of if it's within the range of 101 gram and 102 gram. So this, if you write this as a folio, this will be your problem statement. Your problem statement is the quality controller is going to use the predicted confidence interval for mean weight of ground coffee based on the sample and make a decision whether to adjust or not to adjust the machine by referring to the interval of 101 gram and 1020 gram. Do you get me? So that will be your problem statement that include the parameter of interest. So the parameter of interest and the problem statement not necessarily be a claim. It can be in this form as well. That will help you to make the decision whether to do something or not to do something. Hello? Do you get me? So that is the reason I want to discuss this question. So there is no claim here. You see, there is no claim here, but there is a criteria for you to decide whether to adjust or not to adjust the machine. Okay, got it? Okay, so now we continue to do the part B. So your problem statement doesn't mean must be the claim. Huh? It can be a criteria for making certain decision. Okay, so what is the smallest sample size for which it is possible that the quality controller will not adjust the machine? So we know that the mean must be within this value, correct? 1010 and 1020. So it means that the desired is 1015. So this is the lowest, it go, and this is the highest, is go. So this is the width. So you put into the formula. So 2 times, we still stick to the 95% confidence, that is 1.96. Standard deviation still 10. Okay, what is the width? Cindy. Cindy, can you tell Ms. Doe what is the width? Cindy, can you tell me what is the width?
10.
Huh?
10.
9, 10. Yes. 1020. What happened to you? How come so many people left? You know what happened? Suddenly so many people are out. Huh? Got kicked out. Oh, disconnected. Not I didn't kick out anyone, okay? Internet unstable. You can come to the class. I'm in the class. If you are in college, you can come into the class. I'm in the class now. Okay, so the answer is a 10. Yeah, so square. So what is the answer? After you have calculated? Can you give me the answer? Huh? So small? Did you square it, Bram? You forgot to square it. Yeah. So it's about 16, is it? So here is 3.92. So it's about, okay, so it's about 15 point something, correct? So therefore, the smallest number is always must round up, okay? 16. Yeah. 15.4. So it must be round up. Remember, always must round up, okay? So the smallest number of n is 16. Got it? Okay. So we go to the next part. Okay. So I said part 1 and part 2, you use the Z interval. So the sample mean that they get is 1013. And the predicted mean means the confidence interval, okay? You get from your graphic calculator. So what is the answer? Round off to the nearest gram, okay? Okay, 1009.1. Okay, 1009.4. And here is 1017. Okay, look at here. Look at here. This is your middle of the sample mean, 1013. So you get the lowest possible predicted is 1009.4. And this is 1017. Desire is 1010 and 1020, correct? So look, is this confidence interval within the desire interval? That is fixed. Yes, it's within, correct? So now when you do number 2, you use X sample mean of 1017. So you get the predicted mean. That is also means the confidence interval. Okay, may I know what is the highest possible? May I know what is the highest possible? 1016. 1020.6. And 1013.4. Okay, so this one go like that. 1020. Yeah, then this is 1013 with the mean of 1017. Okay, so it's also within the desire. Okay, so if you have a look at these two, so how are we going to do part 3? Okay, why they give you these two value? Why they give you these two value? if I got the mean of, if I got the sample mean of, okay, so this is my explanation of how to do part 3. If the sample mean that I obtain is less than 1013 gram, what will happen to the confidence interval? What do you think? What do you think? What will happen to the confidence interval that I obtain? Nick? If you want to try, okay, if you don't know what is the answer, if you want to try, you may try to get 1012 and see. And try to find the confidence interval, see how it works. Next.
Yes.
What will happen? What will happen to the confidence interval? Will it be within the desired range that is fixed? This is a fixed desired range. It must be there. It cannot go lower than 1010. It cannot go higher than 1020. Will you get a confidence interval that is, the lower one will be less than 1010? Nick, did you the rest? Did you punch in the graphic calculator? It got less than 1010, correct? So which means that this particular part is telling you this is the lowest possible sample mean that you can take. So that you don't have to adjust the machine. And this will be the highest possible mean that you can take, so that you don't have to adjust the machine. So that's why part 3, you must find the probability that the sample mean lowest is 1013 and the highest is 1017. So you are talking about the sample mean distribution. Okay, so you have to use normal CDF 1013, 1017. The middle is, what is the mean? 1015. Correct or not? Because the question said that the desired value of mean of 1015. And the standard deviation of it will be 10 divided by, Kevin? Divided by, Kevin, are you in the class? Hello. Divided by what? Okay, look, 10 is the standard deviation of the population. I'm talking about sample mean distribution now. According to central limit theorem, what is the sample mean distribution? The standard deviation. Yeah, divided by square root of 30. Then you get the probability. Are you clear? Hello? Student, any question on this? Okay, why is the limit 1013 and 1017? Look, we are talking about, if you read the question, you say, suppose that when the sample of bag is selected and the mean is 1015, find the probability that the quality controller will not adjust the machine. How the quality controller decide not to adjust the machine? How you decide? If you look at part 1 and part 2, the quality controller select a sample, find the sample mean. From the sample mean, the quality controller calculate the confidence interval. If the confidence interval is within the fixed value here, then I don't have to adjust the machine. So from part 1 and part 2, you know that the lowest possible sample mean should be 1013. If it's less than 1013, like for example, I take 1012, the confidence interval will be out of the fixed range. And the highest possible sample mean is here. Okay, I've explained that. Okay, another question is, okay, why the question above part B say that the quality controller will not adjust if confidence interval is between that? So that is the criteria for me to decide whether to adjust or not to adjust. So that is the criteria. So you see, so that's why I said right from the very beginning, you find confidence interval sometimes is not whether to justify a claim. Okay, someone claims something. It also can be something that help you to decide whether to adjust or not to adjust the machine, or to do this or not to do this. Do you get me? So now, based on whatever you get from part C, actually, do you think the quality controller now need to go and find the confidence interval for all cases? No need. I just need to get the sample mean. Okay, if I know if the sample mean is below 1013, I have to adjust the machine. Or if the sample mean I got is more than 1017, then I have to adjust the machine. So what is the chances of it not to adjust the machine? Can you tell me? Can you tell me? Hello, can I have the answer? From here, is it high or low? Student? Can you give me the answer? Okay, 0.727. Is that correct? Okay. So now the quality controller, every day he will go and get a sample. He don't have to count already because he have the criteria already. So he can make a decision based on this calculation. He can make a decision. So how do they get these two values? How do they get these two values? It's for you to think, for me to tell you later. So that means now if I can reset this question and say the quality controller will not adjust the machine if the confidence interval is contained within the range of 1010 gram and 1020 gram. So what is the lowest possible sample mean and what is the highest possible sample mean, so that the quality controller will not adjust the machine? I can ask question like that. This part I give you. This question they give you, but I can change this. So how am I going to count if the question is phrased like that? So go back and think about it. Tomorrow we will think of how to count. Are you okay? You know my question, huh? How actually how people get these two values? That's what I'm interested in. Is it possible for me to get if the question didn't give me? Go and think about it and see how you go. Okay? Student? So this question is very different from other question in the textbook. So you look at your past year paper, all are like that. They can ask you anything under the sky for probability. I can't even predict for you. Every year different. Okay? So thank you, class.